You probably know that plants get their energy from the sun through their leaves in a process called photosynthesis. We humans don't have our own leaves, but maybe you can get energy from the sun in a different way. Electrical energy, that is. Could there be some kind of electrical leaf? A solar cell gathers light from the sun and generates electricity just as a leaf generates food for a plant. Let's find out how. The sun emits energy in the form of waves. These waves can range in length from the short ultraviolet waves through the rainbow of the visible spectrum to long infrared waves. When the sun is shining, these waves move towards the earth and hit the surface of solar cell. Let's take a closer look. The active part of solar cell is a wafer made of semiconductive material, typically silicon. A semiconductor is a type of material that normally doesn't conduct electricity well, but it can be made more conductive under certain conditions. The semiconductor part of a solar cell has three layers. The thin top layer contains silicon and a very tiny amount of element, such as phosphorus, that has more electrons than silicon. This gives the top layer an excess of electrons that are free to move and make the material more conductive. The top layer is also called negative type or N-type, as it favors the collection and transport of electrons. The thin bottom layer contains both silicon and an element such as boron that has fewer electrons than silicon. This gives the bottom layer fewer electrons that are free to move, therefore making the material less conductive. For electrons, a missing electrons can be described as a fictive positive charge. Therefore, the bottom layer is called positive type or p-type, as it preferentially favors the collection and transport of these positive charges. Also doped holes. The thicker middle layer has only slightly fewer electrons, making it marginally p-type. Thin metal lines, typically made of silver, are printed on the top N-type layer, and the bottom p-type layer is in contact with the aluminum plate. When light waves hit the top surface of the silicon solar cell, only light with the wavelengths from the specific window of the solar spectrum 350 1140 nanometer are absorbed into the middle layer of the solar cell. This range of the wavelengths includes the visible spectrum. Ultraviolet wavelengths are so short they stop at the surface, and infrared wavelengths are so long they cannot be absorbed and pass right through the cell or are reflected back. The light wave knock an electron off a silicon atom, setting the electrons loose or leave.
Separated,
An area
connecting a wire between the top and the bottom metal electrodes provides a pathway for the electrons to move towards the holes. Flow of electrons is electrical current. One solar cell produces several watts of power. This may be sufficient for running a calculator or a phone charger, but it's not sufficient for running a toaster, for example, which uses 1,000 watts. So, several solar cells, typically 32, are wired together to make a solar panel. Several solar panels are needed to generate enough electricity to power a household. As leaves generate food for plants directly from the sun's rays, solar cells are a viable way to convert the sun's rays directly into electricity that we can use. Future challenges include improving the efficiency by which a solar cell converts sunlight to electricity and making the solar energy cheaper. Of course, solar cells produce electricity only during the day, so storing the electricity efficiently for use during nighttime is another important challenge. Advancements in solar technologies present the potential to power our lives if we just leave it to the sun.
Electricity to power a household like leaves. Solar cells are a viable way to convert the sun's ray directly into electricity that we can use. Future challenge includes improving the efficiency by which